The vector product, which is also referred to as the cross product, can be expressed as follows. We can calculate our moment of force about point O as our cross product of P and Q. Now, M sub O is equal to our moment arm P crossed with our force vector Q. And we use the time symbol here. This does not indicate multiplication, rather that we are taking the vector cross product. And when we solve for the vector cross product, we have to take the determinant of the following array. The first row is populated by our unit vectors, I hat, j hat, and k hat. The second row is our moment arm, the x, y, and z components thereof. And the third row is the x, y, and z components of our force vector. This cross product involves taking the determinant of this 3x3 array, which we can do by breaking it down into 3 separate 2x2 arrays and taking the subsequent determinants thereof. That is, we can say P cross Q is equal to the determinant of Py, Pz, Qy, Qz in the I hat direction, less the determinant of Px, Pz, Qx, Qz in the j hat direction, plus the determinant of Px, Py, Qx, and Qy in the k hat direction. When we evaluate this, our first determinant yields Py, Qz minus Pz, Qy, and this is in the I hat direction, less our second determinant, which is evaluated as Px, Qz minus Pz, Qx in the j hat direction, plus our last determinant, Px, Qy minus Py, Qx in the k hat direction. For example 3, we want to determine the moment of force about point O in units of newton meters, given our radius, i.e. our moment arm, is equal to 27 centimeters, and our force vector is described as 40, 35, 0 newtons. To do this, we are going to use the cross product. Our moment of force about point O is equal to our moment arm cross our force vector, and we'll populate our 3x3 determinant. And our first row is populated by the terms I hat, j hat, k hat. Our second row is our position vector, i.e. our moment arm, which is 0.27 meters in the x direction and 0 meters in the y and z directions. Our last row is our force vector. We have 40 newtons in the x direction, 35 newtons in the y direction, and 0 newtons in the z direction. Now to evaluate this, we are first going to determine the determinant of our 2x2 array in our I hat direction, where we'd have 0 meters times 0 newtons minus 0 meters times 35 newtons in the I hat direction. That is, we have no moment existing in the x direction, less the moment existing in our j hat direction, where we'd have 0.27 meters times 0 newtons minus 0 meters times 40 newtons. In the j hat direction, we don't have a moment existing. Last but not least, we'll execute the determinant in the k hat direction, where we'd have 0.27 meters times 35 newtons minus 0 meters times 40 newtons. Thus, our moment of force about point O is 9.5 newton meters in the k hat direction.